making sense of solving equations and transposing formulae. In this lesson, we will see how to solve equations and how to transpose formulae. In our first example, we want to solve the equation 3x plus 4 equals 19. Now to do that, we work backwards to find the value of x. Starting with x, we're multiplying by 3 to get 3x, and then adding 4 to get 3x plus 4, and the answer is 19. The last thing we did was to add 4, so to undo that we have to subtract 4 from the 19 to give us 15. In algebra, we end up with 3x equals 15. Next, we undo the times 3 by dividing by 3. 3 into 15 goes 5. So that means the x is 5. In our next example, we again are finding the value of x. We'll backtrack once again. We start with x. We subtracted 2 first to get x minus 2. And then we multiplied by 4 to get 4x minus 2, and the answer was 12. That's our starting point. The last thing we did was to multiply by 4, so to undo that we divide by 4. 4 into 12 goes 3. That means that x minus 2 is 3. Next we undo the subtract 2 by adding 2. 3 plus 2 is 5. That means the x is 5. In this next example, we start off with x and we multiply by 5 to get 5x. Then we subtract 2 and then we divide that by 4 to get an answer of 20. That's our starting point. Let's undo each of those steps. To undo the divide by 4, we multiply by 4. 4 20s are 80. Next, we add 2 to undo the subtract 2, so 5x must be 82. And lastly, to undo the multiply by 5, we divide by 5. 82 divided by 5 is 16 and 2/5. Formulae are used in many disciplines to show the relationship between two or more variables. The letter at the start of the formula is called the subject. For example, V is the subject of this formula, which is used in physics to describe motion. Transposing a formula means that we make another variable the subject. In this example, we'll use backtracking once again to make u the subject of that formula. So we're starting off with u, and to that we've added at to get u plus at, and the answer is v. That's our starting point. Going backwards, we need to subtract at, and so we get u is equal to v minus at. A harder example now will make t the subject of that same formula. So we'll start with t. It gets multiplied by a to get at, and then u is added, and the result is v. That's our starting point. Undoing each of those steps, we'll subtract u, so the at has to be v minus u. And undoing the multiply by a is divide by a, so we need to divide v minus u by a. This time we'll make u the subject of this formula. U gets squared first, so we get u squared, and then we add 2as. So we get u squared plus 2as equals v squared. Going backwards, we'll subtract 2as. So we get u squared is v squared minus 2as. And we'll take the square root to undo the squaring. So the result is u is equal to the square root of v squared minus 2as. We've seen that when we're solving equations, the unknown quantities are represented by a pronumeral, usually a letter, and we're trying to find the value of that quantity. To solve an equation, we can backtrack back to the unknown quantity. And to transpose a formula, we can also backtrack to the required subject.